Today we will discuss the problems based on partial differentiation. So we start with the problem 1. If we have a x raised to the power x, y raised to the power y, z raised to the power z is equal to c, then show that at x is equal to y equal to z, the value of del square z upon del x del y is equal to minus x log ex raised to the power minus 1. So this is our problem. So now we solve this problem. So we write down as given that x raised to the power x, y raised to the power y, and z raised to the power z is equal to constant. So this is our equation 1. Okay, so before we start the solution, so we have to check that. That means here we calculate del square z upon del x del y. So del square z upon del x del y. So we see that this z work as a dependent variable. So this z work as a dependent variable and x and y work as a independent variable. So we can write down this as z is the function of x, y. So we treat z as a dependent variable and x and y as a independent variable. So when we are going to differentiate partially with respect to x, with respect to y, so we take that means we are going to differentiate with respect to us. We take y as a constant. We treat y as a constant, but z work as a dependent variable. So we differentiate them partially with respect to x or with respect to y. So we can take log. So taking logarithmic both side. So we write down this as log x raised to the power x, y raised to the power y, z raised to the power z is equal to log c. Okay, so we have log property, log m into n. So we write down this as log m plus log n. So we use this property. So we write down this as log x raised to the power x plus log y raised to the power y plus log z raised to the power z is equal to log c. So again, we use the log property. So that means log m raised to the power n. So this can be written as n log m. So again, we use the property. So we write down this as x log x plus y log y plus z log z is equal to log c. So this is our equation 1. So we start derivative parts from here. So now we write down a differentiate to partially with respect to x. So when we differentiate this equation to partially with respect to x, so we see that, so there are two functions of x in first term. Here is completely y, second term, and this term is z. So we already discussed that. That is when we are going to differentiate partially with respect to x or y, so we treat only x or y as a constant as per the derivative. But z we differentiate with respect to x and y both because z work as a dependent variable. So here we see that the first term. So first we have term x. So x we write as it is, and the second term is log x. So differentiation of log x is 1 upon x plus differentiation of first term, that means x is 1, and we write second term as it is, plus y. So this second term is purely based on y. So we treat y as a constant. So we write the derivative of second term will be 0 plus z log z. So here we have two functions, that means z into log z. So we use the product rule here also. So first term, that is z, log differentiation of log z is 1 upon z into differentiation of z is del z upon del x with respect to x, plus first term z, so differentiation of z with respect to x, we write down del z upon del x, and we write down the second term log z is equal to. So this c is the constant, so differentiation of constant is 0. So this x to this x cancelled, and here we cancel the z to z. So we write down this as 1 plus log x plus del z upon del x plus, or here we can write down it log z into del z upon del x equal to 0. So this we can write down as 1 plus log x plus. So here we can take common as del z upon del x. So when we take common del z upon del x, so we can write down as 1 plus log z is equal to 0. So 1 plus log z equal to 0. So we can write down this as the value of del z upon del x. So the value of del z upon del x will be minus 1 plus log x upon 1 plus log z. So this is our equation number 3. Okay, so now we write down again differentiate to partially with respect to y. So when we are going to differentiate partially with respect to y, so we treat x as a constant. So the derivative of first term will be 0 plus. And second term, we see that y into log y. So we have two terms. So that means we use the product rule, the y into log y. The differentiation of log y is 1 upon y plus differentiation of y is 1 into we write down log y as it is plus. So we do the differentiation of third term also. So that means first term is z into log z. Log z means 1 upon z, and differentiation of z is del z upon del y plus del z upon del y, derivative of first term, into we write down second term as it is equal to log c. Log c means differentiation of constant is 0. So again, we cancel y to y and z to z here. So we write down as 1 plus log y. So this we can write down this as, and the second term we can take as common del z upon del y. So we write down this as 1 plus log z is equal to 0. So the value of del z upon del y, this will be equal to minus 1 plus log y upon 1 plus log z. So this is our equation number 4. Now we see that we have to calculate del square z upon del x del y. So now we can differentiate. So here we write down as differentiate equation 4 with respect to x partially. So with respect to x partially, so then we can write down as del upon del x into del z upon del y. So this can be written as del square z upon del x into del y is equal to. Okay, so this negative sign we take outside, and we have to differentiate partially with respect to x. So we write down as del upon del x into 1 plus log y upon 1 plus log z. Okay, so we do the rule, divide rule. So that means we have denominator. So we write down the denominator when we are going to differentiate this one. So denominator into differentiation of numerator. The numerator having constant value 1 and plus log y. So when we are going to differentiate partially with respect to x, so we treat y as a constant. So differentiation of numerator is 0. Minus, we have a numerator 1 plus log y into differentiation of denominator. So denominator, the differentiation of 1 is constant plus differentiation of log z. Log z is 1 upon z into differentiation of z is del z upon del x upon denominator to the square. So 1 plus log z to the whole square. Okay, so we write down this as 1 upon z. So this is the negative sign also. So we have also negative here. So the negative into this negative, because first term will be 0. So this negative gives us positive sign. And here we write down as 1 plus log y into del z upon del x upon 1 plus log z to the whole square. So this is the value of del square z upon del x into del y. So we have already calculated del z upon del x. So we use the value of del z upon del x here. So we write down as using 3. So using equation 3, so this gives us 1 upon z into 1 plus log y, 1 plus log y upon 1 plus log z to the whole square into the value of del z upon del x. So what is the value of del z upon del x? Is 1 plus log x upon 1 plus log z. So here we have negative sign also. So we take the negative sign, and here we write down as 1 plus log x upon 1 plus log z. Okay, so we write down this as minus 1 upon z. So this can be written as 1 plus log x, 1 plus log y upon 1 plus log z to the power 3. Okay, so the value of del square z upon del x del y is this. So now condition is given. So when we put x is equal to y is equal to z. So the answer we will take into the term of x only. So the answer is given in the form of x only. So this is our answer, x log e x raised to the power minus 1. So we put y equal to z equal to x. Okay. So we write down del square z upon del x into del y is equal to minus 1 upon x into 1 plus log x. Here we put the in place of y is also x, so 1 plus log x upon 1 plus log x in place of z also raised to the power 3. So this gives us 1 upon x into, so this will be 1 plus log x or 1 plus log x, so 1 plus log x to the whole square. Denominator power is 3, so now we have only denominator power is 1. 1 plus log x. So now this you can write down as x raised to the power minus 1 into 1 plus log x raised to the power minus 1. Okay, so this we can write down as minus x raised to the power minus 1 into the value of log. So, sorry, the value of 1. So the value of 1 we can write down as log e. Log e plus log x raised to the power minus 1. So again, we use the property of log. So the property of log we write down as log m plus log n. So log mn. So log ex raised to the power minus 1. So this we can write down taking negative sign outside, and this x raised to the power minus 1 we also take inside. So we write down x log ex raised to the power minus 1. So this is our RHS part. So we have proved this. Okay. So hope you understand. Now, second question we take in continuation of this. So the second question is that if we have theta, theta is equal to t raised to the power n, e raised to the power minus r square upon 4t. So then find what value of n will make 1 upon r square del upon del r into r square del theta upon del r is equal to del theta upon del t. So we have to calculate the value of n, which make equal to. Okay, so we solve this problem. So given that theta is equal to t raised to the power n e raised to the power minus r square upon 4t. So this is our equation number 1. So this equation, first we solve the this LHS part, then we solve the RHS part. So we start with the bracket. So that means first we have to calculate del theta upon del r. So differentiate 1 partially with respect to r. So you can see that here the theta is function of two variable. One is t, second is r, because we are going to partially differentiate with respect to r and t. So, okay, so theta is the function of r and t. So that's why we differentiate partially with respect to r, then we differentiate with respect to t. So this gives us a del theta upon del r. So we have only one function which have r. So t raised to the power n is constant. So we write down t raised to the power n into. So the derivative of second term. So the derivative of second term is equal to e raised to the power minus r square upon 4t, r square 4 upon 4t into derivative of this. So derivative of this means we write down derivative of minus r square upon 4t. Okay, so differentiation of this term. So we write down this as t raised to the power n e raised to the power minus r square upon 4t into differentiation of minus r square upon 4t with respect to r is minus 2r upon t. So minus 2r upon 4t. Okay, so this can be written as 2 2 ja 4. So minus 1 upon 2, minus 1 upon 2, and r or t raised to the power. So here we have t raised to the power n or upon t. So means we can write down as t raised to the power n minus 1 or e raised to the power minus r square upon 4t. Okay. So now we see that. So the second term when we differentiate further, so we see the LHS part. So LHS parts we have the second term, that means we multiply del theta upon del r with r square. So this is the value of del theta upon del r. So now as per LHS, so we multiply. So write down as multiply both side with r square. So when we multiply both side with r square, so this gives us r square del theta upon del r is equal to. So here we multiply with our RHS also. So we gives us r raised to power 3 because we have one r here. So we multiply by r square. So r raised to power 3 into t raised to the power n minus 1 e raised to the power minus r square upon 4t. Okay. So now again we see that the LHS part. So that means now we differentiate this with respect to r. So del upon del r. So now again differentiate above equation with respect to r partially. Okay, so we write down this as del upon del r into r square del theta upon del r is equal to, so we take as minus 1 by 2 into t raised to the power minus 1 as a constant. So we take outside and the derivative of we take r terms only. So r cube e raised to the power minus r square upon 4t. Okay, so we differentiate this with respect to r. So we have two terms of r, that is first and second. So we use the product rule. So we write down this as minus 1 upon 2 t raised to the power n minus 1. And we write down the first function, that is r cube, and differentiation of second. So the differentiation of second we write down r square upon 4t into differentiation of r square upon 4t is minus 2r upon 4t. Okay, so plus the differentiation of first, so that means we write down 3r square into second as it is. So minus r square upon 4t. Okay, so this we can simplify as, so minus 1 upon 2 into t raised to the power n minus 1. So here we write down this as minus 1 by 2. This will be r raised to the power 4, r raised to the power 4 upon t into e raised to the power minus r square upon 4t, or plus 3r square e raised to the power minus r square upon 4t. Okay. So now again we see that the LHS part. So we also do the product of 1 upon r square into LHS. So here this is the value of del upon del r into r square del theta upon del r. So we multiply both side by 1 upon r square. So when we multiply both side by 1 upon r square, so we see that, so this gives us minus 1 by 2 t raised to the power n minus 1 into, when we multiply this by r square, so this we write as r square of r raised to power 4 upon r square, so gives us only r square, or e raised to the power minus r square upon 4t, or plus 3 e raised to the power minus r square upon 4t. So this is our LHS part. So we give this as equation number 2. So we give this as equation number 2. Now we do for the RHS. So this is our LHS part. Okay. So now we do the RHS. RHS means we have to calculate del theta upon del t. So we write down as differentiate 1 partially with respect to t. So we write down a del theta upon del t is equal to. So we see that, so there are two term of t here. So we use the product rule. The first is t raised to the power n, and second is e raised to the power minus r square upon 4t. So we write down as first function t raised to the power n into differentiation of second. So del upon del t into e raised to the power minus r square upon 4t plus differentiation of first. So n t raised to the power n minus 1, and write down second is e raised to the power minus r square upon 4t. So we do the first part. So this can be written as t raised to the power n into e raised to the power minus r square upon 4t, and differentiation of this. So we write down a del upon del t into differentiation of r square upon 4t. Okay, plus n t raised to the power n minus 1 e raised to the power minus r square upon 14. So this equal to t raised to the power n into e raised to the power minus r square upon 4t. So the derivative of 1 upon t is minus 1 upon t square. So minus minus plus, this can be written as 4t square plus n t raised to the power n minus 1 e raised to the power minus r square upon 4t. So this is the derivative of theta with respect to t. So now when we simplify this as, so we write down this in as in terms of LHS. So we simplify this as, so we write down as 1 by 4, or here we have t raised to the power n, or here we have a t square. So this can be written as t raised to the power n minus 2 into r square. So r square we write down here r square, or e raised to the power minus r square upon 4t, or plus n t raised to the power n minus 1 e raised to the power minus r square upon 4t. So this is our RHS. So when we put LHS equal to RHS, so put LHS equal to RHS. So we, that means from 2 and 3. So this equation we write down 3. So 2 and 3. So the our equation 2, we simplify that. Uh, First we write down as minus 1 by 2 t raised to the power n minus 1, t raised to the power n minus 1, or minus 1 by 2t minus 1 by 2t r square e raised to the power minus r square upon 4t plus 3 e raised to the power minus r square upon 4t. So this equal to this RHS part. So 1 by 4 r square or t raised to the power n minus 2. So this we write at t raised to the power n minus 2 e raised to the power minus r square upon 4t plus n t raised to the power n minus 1 e raised to the power minus r square upon 4t. So now we solve this LHS. So minus minus is plus. So 1 by 2 into 1 by 2, that is 1 by 4. 1 by 4. So here we have the power t raised to the power n minus 1 or upon t. So this gives us t raised to the power n minus 2 into r square e raised to the power minus r square upon 4t plus. So this is plus sign, but here we multiply by minus sign. So this gives us negative sign. So this equal to minus 3 by 2 t raised to the power n minus 1 e raised to the power minus r square upon 4t. So this equal to 1 by 4 r square t raised to the power n minus 1 e raised to the power minus r square upon 4t plus n t raised to the power n minus 1 e raised to the power minus r square upon 4t. So this term will cancelled by this term. So we have minus 3 by 2 t raised to the power n minus 1 e raised to the power minus r square upon 4t is equal to n t raised to the power n minus 1 e raised to the power minus r square upon 4t. So we see that the coefficient of n is equal to coefficient of minus 3 by 2. So here we can write down this as n is equal to minus 3 by 2. So when we put n equal to minus 3 by 2, so we get the answer. Thank you.